Okay, so it is Tuesday night. It's Tuesday night, and I want to make sure you guys can hear me. So if you can hear me okay, can someone drop a comment for me? Anything. Whatever you want. Oh, look, you can put emojis in here. I gotta learn this more. Emoji? Wow, look at that. Did it work? I don't know if it's working right now. Okay. So, all right, I've been messing with this for a minute. My computer's really, really slow. All right, all messages are visible. Let's change that. Okay. I hope you can hear me. I've got one little dot on the microphone, so hopefully that's good. And I'm trying to see. Okay, so, oh, thank you, Maggie. There we go. Okay, there's only a couple of you on the video, so that's actually probably good because the couple of you watching, I can answer whatever you want. But before I get to questions, there's a couple things that I did want to cover. The stuff I want to remind you of or go over or review, predominantly from Unit 3, talking about cost curves and perfect competition, because those are two very important topics to make sure you grasp fully for the test on Friday. And then I also have on my list, I have 4 big errors, the 4 most commonly missed things in this paper. And I wanted to make sure I go over those as well. It's really dark in my house right now, so I'm going to flip on a light and see if that helps the view. Let me see what happens when I turn this on. Wrong light. Wrong light. There we go. There's a light. And then turn on another light. Okay, so in Unit 3, we're looking at cost curves. And when we are talking about the different cost curves, you guys need to remember that we covered 7 cost curves, or the 7 different cost measures of a firm. And we looked at all of the different cost curves that they have there. I still don't think you can see me very well, but it's going to be what it's going to be at this point. So the different cost functions and the formulas for those are things you need to review. If you are in my class this semester, I gave you the review packet with the set of formulas. And if you flip to that page, the formula page, it has the list of all the different costs, right? Total cost, which is fixed plus variable. And then the average, which is the average total cost is the total divided by the quantity. And then it also goes through the average fixed cost, the average variable cost, and marginal cost. Now, the thing you need to remember is that marginal cost is the change in, right? Change in total cost. Where's that one? Trying to find it. No, that's productivity. Here. Change in total cost divided by change in output. Right there. Okay. It's your marginal cost. Now, I want to review what these cost curves look like, and I have a graph for you of that. So, our cost curves, guys. You need to remember that we always have our money and our quantity. Now, average fixed cost will always be decreasing because your fixed cost is fixed. It's constant. It doesn't change. So when you divide that by an ever increasing quantity produced, the average of your fixed cost will always be downward sloping, and it'll get lower and lower and lower and lower and lower, but it will never go negative. Excuse me. And then your other cost curves are higher up. Up here you have your average total cost. That should be the top. Total is your top. Variable is in between your total and your fixed, because to find total, ATC, is AVC plus AFC. And then we also have on here our marginal cost curve. Our marginal cost curve is a Nike swoosh. All right. We always draw it as a Nike swoosh. And the reason for the marginal cost curve shape is because our marginal cost will decrease until we hit our maximum point of production, until our productivity is maximized. And then once our productivity is maximized, and our productivity starts to fall, then our costs start to go back up, which is why we get that Nike swoosh shape. So the Nike check. So I want you to think back onto our push-up machine that we did. And as I hired more and more people, at first hiring people was a good idea. It increased my productivity, decreased my marginal cost, and made me more money. But eventually my workers became less and less productive. So it wasn't necessarily the best for me to continue to hire. Okay, so those are our cost curves, and we need to make sure we know the cost curves. All right. Okay. And then the other thing on the most common errors, people misunderstand diminishing returns and diminishing marginal returns. And that has to do with that Nike swoosh shape. Because remember, our cost curve, our marginal cost, our MC curve, is the exact mirror image of our marginal productivity curve. So our productivity goes up until it hits its maximum, and then it starts to fall. And we start to incur diminishing returns, meaning that in the beginning, we have increasing returns. Making a unit makes us money. Make a unit, make more money. Make a unit and make more money. And then we'll hit this point of diminishing returns where we're going to make a unit and actually make less money than we did before. We're still making money. We're still in the green or in the positive or in the black or whatever you want to say, but we're not making as much as we did before. So before we made more profit than we do now. And then as our returns diminish and diminish and diminish, eventually we'll hit a point where our marginal returns will go negative. And that means that making that next unit actually will cost us more than we will make from it. We will actually have the negative return on our investment. Okay. So make sure you understand the returns and when returns make you money or lose you money. Okay. So I'm going to check that one off because I talked about that one. I want to make sure I hit all of these common errors for you guys. Okay. So now important graphs that we need to know. The first one was cost curves. Well, I already talked about the cost curves graph and what that graph looks like. So I'm going to check that one off. I'll answer questions later if people have questions, but I want to just let you know that's what the cost curve looks like. Okay. Next most important graph is perfect competition. The perfectly competitive graphs, I don't know how to stress this to you without you getting worried, but you have to know perfect competition graphs. You have to know the side-by-side graphs. You have to be able to draw them perfectly. And there's no excuse at this point in time for you to not know a perfectly competitive side-by-side graph, okay? It's on this page of your packet. You have economies of scale and diseconomies of scale at the top. Perfect comp is in the middle, and imperfect is in the bottom. So we're here in the middle on this perfect comp side-by-side graph. And I'm going to hold it up, and then I'm going to describe some of the key characteristics that you need to know. Okay, here we go. So perfect comp. We have our market graph, our industry graph right here. That industry graph has our price axes, our quantity axes, and then our supply upward sloping curve, downward sloping demand curve, and our equilibrium point setting our price and our quantity in the market. Now you have to remember, key phrase, perfect competition are price takers. They take the market price. So whatever the market sets as the price right here will drag across and become the perfect man right there. Straight line, Mr. DARP. MR equals D equals AR equals P. Mr. DARP. Again, with our axes P and Q, and price at equilibrium and quantity at equilibrium. Now, the other thing we added on here is this marginal cost curve, that Nike swoosh marginal cost curve. And over here, this is labeled Y, all right? It should say ATC. I'm sorry, it says Y, but call that curve ATC, our average total cost. Now, this firm is operating at LRE because right here you have MR equals D equals AR equals P equals MC equals ATC. Okay, and that means we're at long run equilibrium because everything is equal. Everything is the same. So that is how we know we're at long run equilibrium. ATC. Okay. Now, it is not always the case that we will be at long run equilibrium. Sometimes they will tell you that a firm is operating with a loss, or sometimes they'll tell you it's operating with a profit, and you need to know how to graph those as well. So here is a side-by-side curve where there's an economic profit. Okay, so on this side-by-side graph, you can see ATC falls down here beneath the price, beneath Mr. Darp. So we have created this economic profit region between price and ATC, because that's what determines our economic profit. Is if price is higher than our cost, right, that means we're making money. A loss would be graphed with our ATC curve above Mr. Darp, and that means we're losing money. I want you guys to remember that. I made you do this quiz like 100 times where you had to draw this graph, and you put, if ATC and AVC are below, you're making money. If ATC is above and AVC is below your price, you're losing money, but you do not shut down. If ATC and AVC are above your price, you are going to shut down because you are losing money so rapidly you cannot recoup that. Okay? So remember, those are why we are going to. I saw your question, Quinn, and now I got distracted because I'm already answering it in my head. So you have to know the shutdown decision and where we are for profits. Now, I want you to remember economic profit and normal profit and accounting profit are all different. Accounting profit only accounts for explicit cost, and economic profits account for explicit costs like wages and rent and your bills, as well as implicit. Economists consider your opportunity cost, what you could be doing with your money that you're not because you're putting it into this business, and they include that in to the calculations. So economic profits are always greater than accounting profits. Additionally, when we say normal profit, we mean break even. So if they're operating on a normal profit, they are at that break even LRE point where MR equals C equals D equals AR equals P equals ATC. That is a normal profit. If you see something say super normal profit or above normal profit, that means that they're making that economic profit on top of that break-even point. Okay, so Quinn, why does the ATC curve drop and then rise again? The ATC curve and the AVC curve, the average total cost and average variable cost curve, will drop until they hit the marginal cost curve, and then they will go back up. Their minimum point is at the AVC curve, or I'm sorry, at the MC curve for both ATC and AVC. And the reason is because as your output is increasing, your costs are going to decrease. And then eventually you hit a point in production where your costs are going to go back up. The marginal cost is the cost of making one extra unit. So if those costs start to go up, slowly your average is going to get pulled back up, and your numbers are going to, I just totally blanked out. I'm sorry. And your numbers are going to skew higher. Okay. So when your marginal cost is dropping, your average total cost and average variable cost are dropping. And then your marginal costs start to go back up. And your average total cost and average variable cost will continue to fall until they hit the MC curve. And then they're going to pull them back up. Okay. So, your ATC curve is also the mirror image of your total productivity curve. All right. Just like your marginal cost curve is the mirror image of your marginal productivity, ATC is your total productivity. So when ATC is at its minimum, total productivity is at its maximum point. All right. So that's why your costs are falling. Your ATC curve, your cost or your total costs are going to fall until your productivity hits its peak. And then once your productivity starts to fall, your costs will start to rise. I hope that answers that question, Quinn. If it doesn't, let me know. Okay. So cost curves. I talked about short run profits. I talked about short run losses. Talked about side-by-side graphs and LRE. Okay. The only other thing I want to make sure I stress tonight with the perfect competition, besides study your graphs, and then study your graphs some more, is changes in the market. And this, yay! Good job, Quinn. That makes me so proud. Okay, now see, I'm smiling because you made me happy. One of the things they like to do, especially on the FRQ, is they ask you to draw the side-by-side graph. You are going to have to draw this, okay? I don't know which one, if you're drawing LRE, if you're drawing an economic profit, or if you're drawing a loss. You're going to have to draw. So you have to know what a side-by-side graph looks like for a perfectly competitive firm. You have to. And then after you draw it, they will give you a situation and they will tell you something in the market changed. Draw the impact. So when you do that, you need to know if that market shifted supply or did it shift demand, and was it to the right or to the left. And then after that, you're going to draw your shift. For example, this is a demand shifting to the right, okay? And then it finds a new Mr. DARP up here, right? Mr. DARP used to be down here at break even, and then Mr. DARP shifted up here, which caused this economic profit. And then if firms are earning an economic profit in the market, other people are going to want to enter and jump in. So that's going to shift supply to the right. I hope you can see that. Can you see it? Kind of. Okay. Supply shifts to the right. That pushes prices back down. And here's Mr. DARP back at that LRE point. Okay. So they're going to give you situations for shifts, and you're going to have to know which way to shift it and how that shift creates a new Mr. DARP. Okay. So that's going to be what you have to know for perfect competition. The other things to remember are that perfectly competitive firms are allocatively efficient because P equals MC. They are productively efficient in the long run because P equals the minimum point of ATC. So they're producing at the lowest possible cost, productively efficient. They're producing where supply equals demand, price equals MC. So they're allocatively efficient. So perfect competition in the long run is a great place to be. Okay, they're the most efficient for market structures. I'm trying to make sure I hit all the points that I wanted to stress. Oh no, you guys, there's a big thing I totally forgot to mention. Most common error. Can you find profit maximization, price, and quantity? If a firm is profit maximizing, what quantity and what price? You know this rule. All right? Profit maximization is found where MR equals MC. Okay, profit maximization, MR equals MC. So in a perfectly competitive firm, find where your MC curve, find where your MC curve intersects Mr. DARP. Set your quantity there and charge the price at Mr. DARP for perfect comp, and then you are profit maximizing. So I said that one. Okay. Next error. How do you locate the supply curve for a perfectly competitive firm? A perfectly competitive market supply curve is just your traditional S, and the market demand curve is your traditional D. But when you're looking at the firm's graph, the one on the right side of your side-by-side graphs, what you need to remember is that the supply curve comes between AVC on the MC curve, because MC is your supply. It's on your forehead. Okay, MC is your supply. So you start at your AVC, intersect with MC, and you slope up. So let me see if I can find a graph over here somewhere. Anyway, okay. All right, here's one that's just cost curves, okay? This is just your cost curves. So the supply curve would start right here and slope up. That would be our supply curve, okay? Now I'm gonna try and find a perfectly competitive firm graph. Perfectly competitive firm. Okay, it's gonna have to be this one. Okay, so on this one, if I'm looking for the supply curve, it's the portion from this point right here up. It's my MC curve from AC all the way up. That's how I would find my supply curve, okay? Okay, and then my last most common error is how do changes in demand lead to long-run equilibrium, or how do they impact long-run equilibrium? And I think I just explained that a minute ago. So that is monopolies, monopolies, monopolies. Doing that next time. I'm just checking notes. Okay. Total revenue graphs. Okay. I can make sure we understand total revenue. Total revenue is found price times quantity. So if you ever have to shade the area of total revenue, you make the square, the price to quantity square on your graph, and you shade it in to find total revenue. The total revenue graph itself is the stacked graph where you have actually, that one's with monopolies, so I'll talk about that one tomorrow. I think that's best if I talk about that one tomorrow. Marginal cost. Yeah. Yep. Quinn, you are going to do great. I promise you are going to do great. Okay? Just, I need you to trust me. I need you to trust me. Okay. Oh, here, because you asked earlier, Quinn, about why the ATC curve drops and then rises. Here is our total, this is our total productivity graph. So you can see total productivity goes up and then it starts to go down. And that is the mirror image of ATC, okay? So that's how we find our ATC curve. It's our productivity curve upside down. And our marginal cost curve is our marginal productivity. So you can see here, marginal productivity looks like the Nike swoosh. It goes up and down. Well, no, it's like a little mountain here. But when you flip it upside down, it's your Nike swoosh. It goes whoosh. So that's how we find our cost curves. It's our productivity curves upside down. All right. So for the 4 of you, because we're having like a small group session right now instead of the 100 of you, that's all the topics I wanted to make sure I talked about tonight. Do you have any other questions or anything? I kind of told you things to just study and practice drawing yourself. You really have to just draw it until you can do it from memory, the side-by-side graphs in perfect competition. I'm going to give you a few minutes to come up with or let me know if you have questions. And then if you don't, we'll call it a night. Maggie, yes, I will draw it out right now. Let me get my piece of paper ready. Quinn, the best way I think to learn the formulas is to realize it's the same formula over and over and over again. And I promise it's that simple. I'm going to start by telling you the total cost. Total is fixed plus variable. Fixed equals total minus variable. Variable equals total minus fixed. If you just know the way those three go together, you know those formulas. Average total is total divided by quantity. Average fixed is fixed divided by quantity. Average variable is variable divided by quantity. So far, I just gave you 6 formulas, okay? I gave you 6 formulas, but I feel like I said the same thing 3 times, and then I said the same thing 3 times. The only other one is your marginal cost curve, and your marginal cost is your change in total cost divided by your change in quantity. So just look at the change. What was our total? How did it change? How did it change? The best way to remember that, marginal means additional. If you're finding marginal utility, it's your additional utility. Marginal cost is your additional cost. Marginal revenue is your additional revenue. The word marginal means additional in econ. So that's the best way to memorize the cost curve formulas. Okay, so Maggie, side-by-side graph steps. Okay, I'm starting with a blank piece of paper, right? First thing we do is we draw our axes. Label your P's and your Q's. Then we need to make one the industry or market and one the firm. Okay. Have I lost you yet, Maggie? Hope that was pretty straightforward. Okay. Now, where people start to screw up, okay? The industry is all the companies together. That's combined. That's your market graph. So I need supply and demand on this side, okay? There's never supply on this side, only on this side, okay? So oh, I wasn't holding that high enough. Okay. All right. Now I'm going to label my equilibrium. Now, because this market is perfect competition, I have the perfect man. So I need to take my price right here and drag it all the way across to make him perfect. So. Now that I have my perfect man, I need to add my cost curve, my Nike swoosh. And then I need to find my profit maximization quantity. This is their quantity. This is how much is going to be made total. But how much should this company make? This company should produce where MR equals MC. Now, I labeled this QF because that's the quantity For the firm, this is QE because it's quantity at equilibrium. Sometimes they tell you to write QM for the market or QI for the industry. Label it whatever the question tells you to label it. Make sure you follow directions, okay? So there is the basis. Even if you don't do anything else correctly, this will get you marks, okay? Even if you screw up after that point, that is going to get you marks, okay? Now, the next question, the next step is going to be question dependent. So I can't tell you exactly what should be next. It will either tell you that this firm is at a loss, this firm is at a profit, or this firm is breaking even. They have a normal profit. They're at long run equilibrium. What they'll do is they'll throw all these things at you to see if you know, do you know that break even equals normal profit equals long run equilibrium, that you graph all those the same? Would you know that? That's one of the things they want to test. Do you know that to graph a profit, ATC is above the price? To graph a loss, that ATC is below the price. The other thing they'll say is that they are at a loss, but they are not shutting down. So if it's a loss with no shutdown, that means they want both ATC up here and AVC down here. So I'm going to show you how to graph a loss without shutting down, okay? Because that's what came to my head, so that's what I'm going to graph right now. All right, so if it is a loss, that means my costs are greater than my revenue. So my cost is higher than P times Q. So here's ATC. All right, so I put my ATC curve in the correct spot, but I would not get the full points because they're going to want me to shade the loss. So to shade the loss, I have to see that my price is here, my quantity is there, but my cost is up there. So I have to drag my Q up to my cost curve, drag that over to my price axes to find out how much it's actually costing me to make this product, and then shade how much money I'm losing. There's my loss. Okay. Now, if I'm not shutting down, that means my AVC curve, my average variable cost curve, is down here. If I am shutting down, my AVC curve would be above the price. Okay. All right. So that's a side-by-side graph with an economic loss. If I were graphing a profit, this curve right here would drop down here, and this shaded box would be from my price down to my cost curve. Okay. So there's side-by-side graphs. Make sure we are masters of side-by-side graphs. Okay. So Quinn and Maggie keep talking to me, but I don't know who the third person is. There's only 3 of you guys watching this right now. Whoever person 3 is, hey, what's up? I'd give you a shout out. Oh, it's Alexis. This is like a Blue Barracuda private thing happening right now. It's crazy. You guys are still short 2 people though. I don't know where the rest of your team is. Do you guys have any other questions? Since no one else is watching, can I say like the Blue Barracudas are the best table, or would I get in trouble for that? FRQ from your exam. Alexis. Okay, give me 1 second because it is over on my dining room table right now. Give me a second. I have to walk over there. Alexis. Okay. Okay. So the one from your exam was actually on Monopoly. And so it's a little bit different than what we've talked about so far. And I think I have Monopoly pages here too. And I'm going to go into Monopolies in depth more tomorrow. But since you asked and you're here, they wanted a monopoly operating at a loss. So you have to draw the monopoly graph with your D not equal to MR. Remember, D is above MR in the monopoly graph. And then if it's at a loss, like I just said a million times, your ATC curve has to be greater than price times quantity. So it's got to be above your demand curve, Shoot, that just closed. I'm going to try and find a graph in my stack here of graphs that matches what I'm talking about. It's perfect comp. This is a monopoly with a profit. It's a profit. It's a no. Profit. Here we go. Okay. Now this one is really, really close. So I know in this graph, he's trying to draw a long run equilibrium. He's just not able to hit it. But you can see in this monopoly graph, you have, I'm trying to find a pen that I can point with so that way you can see better what I'm trying to talk about. Okay, so here we have our MR and our D, our Nike swoosh MC, MR equals MC for quantity, go up for price. And now he touched ATC right there, so he's going for long run equilibrium. But what you needed to do for the exam, Alexis, was put ATC up here. It had to be higher because if it's at a loss, ATC has to be way up high. So that's where that is. Now let me read what the question was asking. Okay. So you had to draw and label that graph. Profit maximizing quantity, QM at MR equals MC. That was what it was testing you. Profit maximizing price. Did you know that at MR equals MC, you go up to the demand curve to set the price? The ATC curve at the top of the graph. Oh, it also asked for where it's allocatively efficient. They do this all the time with monopolies. Where is it allocatively efficient? Remember, allocation is when supply equals demand. Give the people what they want. So here's your demand curve, okay? Where's your supply curve on this graph? MC, okay? Can you see me, MC? I don't know if you can see what I'm pointing to or not. So supply equals demand would be right here. So your price would be here and your quantity would be there, okay? So that would be allocative efficiency when P equals MC equals D. So that would be the graph. Okay, that was number 1, part A. Then the rest of them was they give them a lump sum subsidy so the firm earns 0 economic profits. Shade the area of the subsidy. Will the profit maximizing quantity change? Increase, decrease, or remain the same? It's going to stay the same. Lump sum is a fixed cost reducer, so that doesn't change marginal cost. So MR equals MC would be exactly the same. It would not change our quantity. Part C says, what if they give them a per unit subsidy? That would change things, because if it's per unit, it's going to shift our marginal cost curve down, meaning that our profit maximizing quantity will change, okay? Because our costs will be decreasing. And if our costs are decreasing, MR equals MC will go up. So we'll make more products because we have lower costs. All right. But our price should stay the same because Mr. DARP did not change in the short run. And then D, will it change consumer surplus? Yes, it will change consumer surplus. But you didn't explain why. So that was the final exam. Oh. So we did an activity in class where you guys did the questions talking about lump sum versus per unit. And lump sum don't actually act as a very good incentive if you're trying to get people to change their output. If you want output to change, you have to do per unit. The same with taxes. If you're going to try to correct externalities and you want to do a tax, you have to do per unit tax to actually get people to do stuff. A lump sum tax isn't going to change things. Okay? All right. Blue Barracuda, is you good? Because if you're good, I'm going to bed. Alexis is good. Quinn, you good? Yes. Oh my gosh, thank you. I have to send that remind out to everybody. All right. Oh, Lauren, see, we got a silver snake from 5th hour jumping in. All right. She was silent the whole time. But yes, I'm going to send that remind out tomorrow, 8 a.m., guys. That's our checkout time, okay? And I will be there at senior checkout. So, all right, guys, have a great night. Study, go practice. Please draw a couple side-by-side graphs until you can do it from memory without thinking, okay? So have a good night, guys, and I will see you tomorrow.